Okay, so we're going to go over transforming sinusoidal functions. Those are functions that repeat a pattern and there are waves, okay? And we're going to do it both degrees and radians. So you may have seen it in degrees before, and if not, that's fine. And we'll go through both. So degrees, converting a degree to a radian, say we have, converting a radian to a degree, say we have pi as our radians, which that may not make sense right now. In order to figure out what that is, pi times 180 divided by pi is actually just 180. So right away I know that pi is equal to 180 degrees. You may think, well, what does that even mean? We'll figure out in a minute. Same idea if I have 180 degrees and want to convert it to radians, well, 180 times pi divided by 180, these cancel out, that's equal to pi. So we know something already, and that's going to help us with what we're going to go through in a second. That small little thing we've done there. So let's talk about degrees. And degrees essentially are kind of working a circle, right? We have a circle here. And we're just going to draw a couple lines through it. We have a line coming through this way and through this way. So here's our axis. Okay. So let's think if we're starting right here, this would be 0 degrees. Up to here will be 90 degrees, 180 degrees. This becomes 270 degrees. And what I'm talking about is slowly moving from 0 to here is 90. From 0 to here is 180. From 0 to here, see how it's a large amount, is 270. And then if we were to go all the way around a circle, do you know what that is?
360.
Yeah, 360 degrees. So if we were to complete this pattern and go all the way to there, we're looking at 360 degrees in terms of rotation. Now we just figured something out. I talked about 180, right? In terms of radians, we'll do the radians in blue. This would still be 0 radians if we just start there. Going to 180, we said was how many radians? Do you recall? It was represented as pi. Remember when I was converting? So this is known as pi. So with that information, let's see if we can't figure this out. So 90 is half of 180, right? 90 is only getting halfway there. So in other words, half of pi as an exact term would be pi over 2. Exactly. Okay. Then again, with that being said, let's go up a little. Passing pi and going to 270, well, that's 1.5. And 1.5 as an improper fraction is 3 over 2. So it's 3 pi over 2. That's what 270 is. And finally, a full rotation would be going 180 times 2. Yeah, exactly. So we have our 2 pi. So those are some important ones. Those are key features of what we're going to do. We'll definitely pull out a couple other ones just so you know them. Let's think of it this way. If this is 45 degrees, right? So if we're going 45 degrees all the way through here, well, 45 degrees in radians, well, 45 is half of 90. So in other words, let's multiply the bottom of this fraction by 2. That's the same as dividing by 2. That would be pi over 4. Exactly. Okay. And then getting from pi over 2 to a full pi, think of it, we're still over 4. But instead of being 2 over 4 would be half. So this is 1 over 4. Think of this as fractions, right? This is 1 pi over 4. This is technically 2 pi over 4. What would this be?
3 pi.
Yeah, that's right. That becomes 3 pi over 4. So 3 pi over 4. This ends up being how much over 4? Do you know? If this is 4 pi over 4, this would be 5 pi. Straight down would be 6 pi over 4. So this would be 7 pi over 4. And over here would be 8 pi over 4. And 8 divided by 4 is 2. That's why those numbers work that way. Okay. Now there are 2 other ones we do want to quickly talk about on each end. And there's a 30 degrees. And there's your 60 degrees. Okay. So they kind of come around like this. These ones are not as intuitive to figure out, okay? But these are the main ones we talk about, okay? And I should have written this in. This is 45 degrees, right? This is 45 degrees, This here is 135 degrees. This here is 45, that is 225 degrees. And this here is 315 degrees. Okay, that's what those 45s are. And then we have a couple in the middle. A couple in the middle, you end up having pi over 6 as your 30 degrees. It's a smaller amount.
So this is going to be pi over 10 and the next one. What on there?
This one here is going to be pi over 3. And that will be 60 degrees. That's what that will represent. Okay, so this is a sixth. This is 2/6. This would be 3/6. So you're looking at another way to look at this. Let me think about this. That is a sixth. Yeah, that would be a sixth. And one way, if we're ever lost on how to figure these out, we know we can use our conversions, right? So 30 degrees. Well, 30 degrees times pi is 30 over 180, and I can reduce that. 30 divided by 180.
How do you know 30 times pi is 30?
I know that's my conversion to radians.
Oh.
So if I have 30 degrees and I'm trying to figure out what it is in radians, I put 30, 30. I'm going to use that because otherwise 0 zooms in. 30 times this. So it becomes 30 pi over 180. Well, these reduce, right?
Are you going to multiply 30?
Yeah, you multiply it, yeah, and that becomes 30 pi when you multiply.
It does?
Yeah, 30 times pi is 30 pi.
Oh.
The zeros will cancel out, and then 3 into here becomes 6. So that's where we get our pi over 6. If we were to move, so this one here, we're to move 30 degrees, 60 degrees. So if we move 30 degrees, this is 120, okay, degrees. Or if we were to plug that in, 120 times this is the equivalent of, if we divide both by, let's say, 3, that's 4 and 6. So this becomes 4 over 6. Yeah, exactly. This is the equivalent of 150 degrees down here. When we use that, 150 times that is the equivalent of 5 pi over 6. Okay, so we're starting to get a pattern here. 4 pi over 6 can also be reduced to 2 pi over 3. Okay, and that's where it's similar to this. So this is like 1 pi, 2 pi, 3 pi, 4 pi, 5 pi over 6. 6 pi over 6, this is like 7 pi over 6. This becomes like 8 pi over 6, but
so the 180, would it be 6 pi then?
Yeah, this would be the equivalent of 6 pi over 6, right? And we know the 6's cancel out, so it's just pi. That's the idea. Here's 7 pi over 6. 8 pi over 6 is also written as, we can divide them by 2. 4 pi over 3. Okay. This would be 9 pi over 6. This, I'm going to move that over because it looks like he's representing this, but he should be down here. This becomes 10 pi over 6, which can be reduced. If I divide them by 2, it's 5 pi over 3. And this is 11 pi over 6, which means the last one will be 12 pi. So this wheel here helps us convert our degrees and radians. We've just actually gone about converting this entire wheel. And I think actually what we're going to do is we'll leave this as a video itself, just as converting degrees to radians and radians to degrees. Okay, so we'll leave that.